Welcome back. In part 2 of my personal 400 cubic inch LS build series, we are going to hone and prep the block completely for assembly. So first we're going to throw the block in our CNC Rottler cylinder hone, and I'm going to show you guys how we hone an LS engine block, especially for a power adder. We're going to put dual torque plates on it, and then we're going to do a plateau hone finish, of course. Then we'll come out of the hone, we'll do a deep clean on the block, we'll deburr the tops of the cylinders, the bottoms of the cylinders, and prep it, structurally for assembly. Then it goes in the wash tank, it'll get washed, it'll come out of the wash tank. We'll install cam bearings, we'll give it a nice paint job, and then it'll be ready for assembly. The machine that we hone our engines in is Rottler's H85AX. And this is basically a fully automated CNC style hone with a 6-cutter hone head. Now the first stage of this hone process, I'm using the equivalent of a 180 grit diamond cutter. There are 6 of these in this hone head, and I'm going to hone the block to the absolute final bore diameter, 4.1250, with these 180 grit cutters. After the block is final sized, we will come back with this 600 grit CBN diamond plateau stone. And this is basically going to give the engine block a smooth, polished finish on the surface. The reason we start with a really coarse 180 grit is I want to cut a really deep valley into the engine block, and then we'll come back and brush and smooth off the face, but we want that deep valley for a lot of oil retention in the cylinder finish. We want that oil retention there because this motor is going to make so much horsepower and see so much cylinder pressure. We want that oil to cling to the wall to help cool off and lubricate the piston rings. So first step, let's get the block thrown into this machine, and then we can put on our torque plates. All right, the block is right now just sitting in the hone. And so now I'm going to walk you guys through kind of the setup of how we get the CNC hone rolling. And so first we'll just lock down the block so that it's secure, just like so. And now we can roll it over. It's on this trolley is kind of on a spring. It's really nicely balanced too, so there's almost no effort. All right. So first we need to kind of write a program for this block. We've done obviously the standard LS blocks a whole bunch, but I don't know if the main webbing is any bigger with this Cleveland main engine. So we're going to write a new program basically for it. So let me do a quick cheat sheet and grab a picture of some of these bore locations just to save me time when I set it up again. All right, so let's do a new program. And let's go ahead and title it. We'll do Dart LSN 2.75 for the main journal. How about that? Okay, we'll do a new hone program. Select it. All right, so we're going to go to a 4.125 bore. For my crosshatch angle, normally on a naturally aspirated LS, I like to run about a 45-degree cross angle. For a moderate power adder combo, I'll run about a 40-degree. I'm going to go down to a 35 on this one. That just feels right with me. We'll set our hone RPMs. I want to RPM it when it's honing rough and finish at 175, and then when we go with the plateau, we'll drop it down to 80. And then we'll enter our loads. I'm going to rough hone it at 50 load, finish it at 40 load, and then we'll plateau it at 15. All right, now we can tell the machine how far down to hone this block, which is going to be based on the sleeve length. So literally we'll come in here and we're going to measure down to the bottom of that sleeve up to the top, getting about 5 7/8 inch. I'm going to go back to my standard LS block program and just check that. Yeah, so I have the exact same information on it. Do 5.8. So let's go back to this one. Close cylinder length 5.85. And we need to set our lower stroke, which is basically how far can we hone down into the block before it hits main webbing. And right now that's at about 6 1/4. So now let's subtract 6.25 minus my 5.8, 5 7/8. And then I want to build in a little bit of a room for error. So we'll lower stroke it 0.35. Check my other program, see what I was doing there. Yep, same, 0.35, cool. So it's actually the same. All right. Now, let's set our bore locations. So let's move this guy over. And we want to bring it down, and we're going to zero this hone head in the first cylinder bore. And then we need to zero out our Z height. All right, that all looks good. All right, now we're going to tell it the bore spacing of the block and where I want it to go next. So we're going to start in this 0 hole, and then we're going to go over 8.8 inches because the bore spacing center to center is 4.4. So for my second hole, we need to go over 8. Then we're going to come back and do minus 4.4. And then we'll do plus 4.4. And so if we kind of run it through the program, it'll hone the first hole, then it'll come to the second hole, then it'll go to the third hole, and then it'll finish on the fourth hole. And the reason we want to kind of jolly it between these different holes in that order is we want to always go to a new hole that doesn't have any thermal or any chance of thermal expansion from honing the previous hole. So if we start in this hole, or let's say we start all the way on this side of the block, and we hone it, and then we go to the next hole. Well, this bridge, this wall between them, there's a chance that there's some thermal heat and expansion happening from the friction generated, or the heat generated from the friction of honing the first hole. So we're going to start here, go to this one. By the time we're done with this hole, this is all cooled off, so we can go back here. And by the time we're done with this hole, this is all cooled off, so then we can go here. That's kind of why you'll see it hone different holes in pattern instead of just going down the bank. All right, we got this left bank clear. Now I'm going to roll it over and use my cheat sheet notes. So we need to start at negative 0.96, 7.84, negative 5.36, and then 3.44. Okay, so let's check this side. Make sure that everything's good, and then we'll put our torque plates on, and we can start honing. Perfect. So we're going to take our torque plates and we'll drop these onto this engine here, about like so. And then we're just gonna torque this down as if it was the cylinder head. No different. And I am using the CMD thread lubricant for this engine build. Right now I'm just going to 65 foot-pounds, and then I'll do the final torque next. I don't know if these little studs up here really affect anything, but let's go ahead and torque them as well, just to cover our bases. It can't hurt, right? Okay, one side done. Now let's do the other side. All right, both torque plates are installed. Block is in the machine. First, we're gonna take a measurement and see how much we need to remove. Which is about 8 thou. So now we're gonna bring our hone head, bring it over to cylinder 1. Let's drop the head into the block. Make sure everything is lined up still. Way in there. And now this hone is really sweet because it will automatically determine the size of the bore, and then all you tell it is how much material you want to remove from the hole. So we're going to feed the stones to diameter. It's now going to spin up, and it's going to find the diameter of that bore. Right there. Now we zero that out, and now I could, in theory, tell it exactly how much I want to remove from this hole to make it perfect, and then it will do all the other holes exactly to match. But I always like to run kind of a quick trial pass in the machine first. So I'm going to tell it to just remove 1 thou and we're gonna run through the whole block, just taking out one thou, just to make sure everything is working correctly, there's no crash detection and no errors in the setup. So now we can go ahead and hit cycle start, and it will do the rest. So it's gonna drop into the hole right now, exactly where I want it, feed the stones out, check itself, then it's gonna drop all the way to the bottom to do a crash detection to make sure it doesn't hit anything on the way down, and then it hones, just like that. And like I said, I'm just gonna take out one thou out of every hole to start. And it'll automatically dwell at certain parts of the bore to make it perfectly straight. Boom, there's 1,000. It'll move to the next hole on its own. While it's moving, I usually come in here and check, make sure everything's cutting straight, make sure it did indeed take out one thou. Everything looks perfect. And yeah, that's how you hone with this rottler. Pretty sick. So I'm gonna go ahead and start a time lapse for you guys, and we will come back when I am ready to plateau finish the block at final size. Okay, I went ahead and stopped recording because it's just honing material out, but the block has now been final sized, and after I final size the block, I want to let it sit and relax for about 30 minutes so that the iron can just settle into place after being forced and pushed and honed on. Now let's come back and we're going to final check our bore diameters, and we'll see how much they have moved around. And then that will tell us if we need to come back and hone certain cylinders to final them to size. So my first hole here, I need to come back and hone it a little bit. Let's go to my second. It needs to get honed still. My third does as well. My fourth hole is borderline. I'm going to come back and just barely bump it. Now let's check this side. Same, that one's a couple tenths too small, couple tenths small, couple tenths small, and a couple tenths too small. So yeah, we're going to come back through and just kiss all of them just a tiny bit to remove the last couple tenths of material. Okay, after touching up the block just a hair, come back and check. Make sure everything's perfectly zero. There's still a couple tenths under. So what's nice about this machine is I can dial in and tell it just to remove one more 10,000th of an inch. Okay, so now this hole is perfect. It's dead on zero. So I'm going to turn off that hole so it doesn't touch it. And this hole is also good. So I'm going to turn off 3 and 4. Let's check this side. 1 is good. Turn it off. Number 2, also good. Let's turn him off. 3 is good. So it looks like this whole side is actually perfect. Dead on zero. Yeah, so all we have to do is just touch up 2 holes on the other side, and this block will be done with our finish hone, and then we'll be ready to plateau it. That's all we needed to remove, just a tiny bit from 1 and 2. All right, now come back and check those 2 holes, and now they are dead on zero. Okay, time to plateau. So I'm going to turn on all of the holes again. We'll put the machine in plateau mode. And now I just need to swap out the stones for our plateau brushes. They're actually not brushes anymore. Back in the old days, these used to be an actual like a brush, literally. But now, just modern technology, we use a CBN type of material, type of cutter. That's it. Now, let me check everything. And we should be good to go. Bring this down. Yep. Cycle start. Now it's going to do it's going to do 5 strokes at a very low RPM and at a very load against the block, just to kind of polish off the surface finish. Just like that. And that's it. And that's it. This block is now finish honed and is completely ready for assembly.